Good morning, all. In today's session, we will see syntax analysis phase. If there is an ambiguity in the grammar, how we can recognize it and how we can remove it. So, in today's session, we will see what is the role of the parser. What do you mean by the context-free grammar? If there is an ambiguity with the grammar, how we can overcome that particular ambiguity with the help of the left recursive method and the left factoring method. Now, what is the role of the parser in compiler design? Basically, in compiler model, the parser contains the string of the tokens from the lexical analysis phase, which is shown in the figure, and verifies that the string of token names can be generated by the grammar for the source program. So we expect that the parser to report such type of the syntax errors and to recover that errors for processing the remaining program. So basically the parser will construct the parse tree and passes it to the rest of the compiler for the further processing. So the parser tree need not construct the parse tree explicitly, since the checking and the translation action that can be dependent on the parsing. So thus the parser and the rest of the front end can be implemented with the single module. Then how we can represent the grammar? So basically here the non-terminal variables that is shown with E, T and F, and the terminal variable that is shown with the ID. So here the E represents the expression that will consist of the terms which is separated by the plus sign. The T represents the term that will consist of the factor which is separated by the into sign. And the F represents the factor that can be either parenthesis with the expression or the identifiers. So here the expression grammar belongs to the class of the LR grammars, which are suitable for the bottom-up parser. So here E which contains E plus T or T, T which contains T into F or F, F which contains E or ID. So such type of the grammar is suitable for the bottom-up parsing. Now, if there is some ambiguity with this particular grammar, then we have to overcome that particular ambiguity. So such type of the grammars is known as a non-left recursive variant of the expression grammar. Basically, that can be used with a top-down parsing techniques. So here, E which produces TE dash, E dash which produces plus TE dash or epsilon. So such type of the grammar that can be used in top-down parsing technique. Then, when the parser will generate the parse tree, it will handle the errors. So what type of the errors it will handle? These are the lexical errors, syntactic errors, semantic errors, or the lexical errors. So what do you mean by the lexical errors? So basically, the lexical errors that will include the misspelling of the identifiers, keywords, or the operators. The syntactic errors that will contain the misplaced semicolons or the extra or the missing braces. The semantic errors that will contain the type mismatch between the operator and the operands, and the logical error that will contain anything from the incorrect reasoning on the part of the programmer to use in the C program of the assignment operator. So instead of the assignment operator, we can use the comparison operator. So such type of the errors that can be obtained with the help of the logical errors. So with the help of the common programming errors, the parser is responsible for the error handling goals. So these goals are report the presence of the errors clearly and accurately, recover from each error quickly enough to detect the subsequent errors, add the minimal overhead to the processing of the correct programs. So when we will say that there are the different programming errors that are used, the different error recovery strategies that are used, which are listed over here. The first strategy is the panic mode recovery method, the phrase label recovery method, the error productions, and the global correction. So here, with the panic mode recovery method, we will discard the input symbol one at a time until the one of the designated set of the synchronizing tokens is found. Means the synchronizing tokens are usually the delimiters such as the semicolon or closing bracket, whose role in the source program is to clear and unambiguous. The phrase label recovery replace a prefix of the remaining input by some string that allows the parser to continue. So here, a typical local correction is to replace a comma by semicolon. So which will detect that it is the phrase level error and we have to recover with the phrase level recovery method. The next one is error productions. So with the help of the error production, we have to augment that grammar with the productions that generate the errors construct. So here, the parser is constructed from the augmented grammar by these error production, which will detect an anticipated errors when an error production is used during the production. The next recovery method is the global correction. So here, by choosing the minimal sequence of the changes to obtain the globally least cost correction, such type of the recovery method is used. Then the next is what is the context-free grammar. So basically the context-free grammar that will contain the terminals, non-terminals, start symbol and the production. So here the terminals that contain the basic symbols from which the strings are formed. So here the term token name, which will be used for the synonym for the terminal. Then the non-terminals are the syntactic variables that denote the set of the strings. The start symbol, which will be used to denote the start of that particular language. And the production that will denote the grammar where the terminals and the non-terminals can be combined to form a particular string. So, as shown in the figure, that is, with the expression which will contain the expression plus term or the expression which will contain the expression minus term. So here, the terminal symbols are the ID plus, minus, into, divide, the opening and the closing round bracket. And the non-terminal symbols are the expression, term, factor, and the start symbol. So based on the terminal, non-terminals, start symbol, and the production, we can define the context-free grammar. Once the context-free grammar is defined, we have to derive that particular grammar with the help of the rightmost derivation or the leftmost derivation. If the substitution of the string is done from the left side with that particular grammar, then it is known as a leftmost derivation. And if the substitution is done from the right hand side of that particular string with the given grammar, then it is known as a rightmost derivation. So here we have taken into the consideration the string which contains minus in round bracket id plus id. So here we have used the substitution for the id, which will be derived from the left side. So it is the leftmost derivation for the given input string. Similarly, we can do for the rightmost derivation. So based on the derivation for the generation of a particular string, we can construct the parse tree. So now again, with the same example for id plus id, we can construct the parse tree in the leftmost derivation or with the rightmost derivation based on the production that is given for that particular input string. So when we will construct this particular parse tree on a same input string, it is possible to construct the string from the leftmost derivation also and from the rightmost derivation also. It means that for a particular string, we can construct the multiple parse trees. So that will create a conflict and which is known as the ambiguity that is occurred with a particular production. So if you want to remove that particular ambiguity, we have to use the two methods. The first one is the left recursive method and the another one is the left factoring method. Now, what is the left recursive grammar? Basically, the left recursive grammar can cause the recursive descent parser to go into an infinite loop. Hence, the elimination of the left recursion must be done before the parsing. So here, if the production which is written in the form of A which produces A alpha, that is, the left hand side of the production is same as the right hand side of the production, then we can say that there is a left recursion occur and we have to eliminate that particular left recursion. So basically the top-down parsing methods can't handle such type of the left recursive grammars. So how we can eliminate the left recursion from a particular grammar? So here the rule is given that if the production will contain A which produces A alpha and A which produces beta, it means that it is the left recursive grammar as the left hand side of the non-terminal is same as the right hand side of the non-terminal of that particular production. Then we can rewrite that particular production. That is the A which produces beta A dash, and again we have to write the production for that A dash. That is the A dash which produces alpha, A dash or epsilon. So in this way, we can eliminate the left recursion from a grammar. So here we have seen one more example, that is the S which produces A or B, and A which produces A, C, S, D and epsilon. So here with the first production, that is S which produces A or B, which does not contain the left recursion, but with the production, that is A which produces AC or SD, which contains the left recursion, as the left hand side of the non-terminal A is same as the right hand side of that non-terminal. So with the help of the algorithm, we have to remove the left recursion. Now, based on the same concept, we will see another example. So here the example is given, that is A which produces ABD or A which produces AA, A which produces A, and the B which produces BE or B which produces B. So if you will look at the grammar which contains the left recursion. So by introducing a new non-terminal variable, that is A dash and B dash, we have to remove the left recursion from a particular grammar. Now the next is, what is left factoring? So basically the left factoring is a grammar transformation that is useful for producing a grammar which is suitable for the predictive or the top-down parsing. So here, if we will consider the grammar, that is if expression, then statement, else statement. Again, if we will consider the statement, if expression, then statement. So if we will look at the input, if it is not clear for the parser, then it will create the conflict. To remove such type of the conflict, the left factoring concept is used. What it means? That with a given production, if there is same terminal variables that are available, then we can group this particular terminal variables into one. What it means? That left factoring, it is a process in which the grammar with the common prefix is combined into one. So here an example is given, that is A which produces alpha beta 1, alpha beta 2. So here the common prefix that is available as a alpha. So we have to generate a new non-terminal variable, that is A dash, and the A dash which contains the beta 1 or beta 2. Now with the help of this, we will see one example, that is S which produces IETS or S which produces IETS, ES or A, and E which produces B. So if you will look at the grammar, there is a common prefix that is available, which is nothing but IETS. So we can combine this particular common prefix. So the solution is the S which produces IETS, S dash or A. And now this S dash which will contain the ES or epsilon. The E will remain as it is, that is E which produces B. So if there is an ambiguity with a given grammar, with the help of the left recursive methods and the left factoring, we can overcome the ambiguity. Thank you.